Let's look at this question. Each of the 6 friends A, B, C, D, E and F had 3 different types of chocolates with them: lollipop, candy bar and waffled bar. The number of chocolates of each type with the 6 friends were 2, 4, 6, 8, 10 and 12. Okay. So we have here 6 friends and 3 types of chocolates with them: lollipop, candy bar and waffled bar. Okay. When you're reading a question, keep on making mental notes as to what is the critical piece of information here. Okay, the number of chocolate of each type of the 6 friends are 2, 4, 6, 8, 10 and 12. Okay, even numbers all around. Further, it was known that no two friends had the same number of chocolates of a particular type. Okay, so 6 friends, 6 different numbers of chocolates. Every friend will have different number of lollipops and candy bars and waffled bars. Okay, also no friend had the same number of chocolates of any 2 different types. Okay, so if a friend has 2, then he must have 4 or 6 or 8 and 10 and 12. So 3 of these numbers. Okay, cool. The table below gives the information about the difference between the highest number of chocolate of a particular type and least number of chocolates of other type that a friend has. Okay, so this is the difference they're talking of. It also gives information about the sum of chocolates received by particular friend of all 3 types combined. Now see, when you read something like this, no two friends have the same number of chocolates and also no friend has the same number of chocolates of any 2 different types. This should give you an indication this question is slightly Sudoku-ish in nature, and that is how you should proceed. Let's write down. I have A, B, C, D, E and F. These are the 6 friends. The chocolates that they can have are lollipop, candy bar and waffled bar. Okay, number of chocolates with each one of them, blah blah blah. So I know, because of this line, it is known that no two friends have the same number of chocolates of a particular type. It means every row will have different numbers. Also, no friend has the same number of chocolates of any 2 different types. Oh, sorry. The first line means that lollipops with A, B, C, D, E are going to be distinct numbers. And the second line, this line, also no friend had the same number of chocolates of any 2 different types, means every row is going to be distinct. Okay. Now when you are analyzing this table, the important thing that you should note is these are differences in sums given to us. Whenever you're dealing with numbers and you have to fit numbers somehow, what works wonderfully well here is extreme cases. Let's look at extreme cases. When you're looking at difference between the highest and the least, the largest difference you can have is when you have 2 with someone and also 12 with that same person. 2 and 12 together give you a difference of 10. So can I say C here with 10 will definitely have 2 and 12 here. Also, we've been told that sum of all 3 types here is 24. Therefore, the third value has to necessarily be 10. So for C, I know 2, 12 and 10 will get used up. Okay, now let's look at difference of 4. Difference of 4 can be obtained with 2, 6, 4, 8, 6, 10, 8, 12. So that is not a lot of help. Let's look at difference of 8. Can I have a difference of 8? I can have a difference of 8 with 10, 2 or 12, 4. Okay, I can have it with 10, 2 or 12, 4. Difference of 8 is known to us. Okay, but if I had 10, 2, the third number I would need to make the sum 26 has to be 14, and this is impossible because 14 is not available. Therefore 12, 4 is the actual case here. So I've got 12, 4, I've got 16. In order to make 26, I would need 10 here. So 12, 4, 10, and this is the numbers with E. So I have 12, 4 and 10. Okay, another way extreme cases can be handled is when you're looking at sum of all 3 different types. When you look at sum of all 3 different types, the maximum possible sum you can get is 12, 10 and 8, which is 30. But 30 is not available. 26 is available. 126 we've already handled. Another 26 when we need. And you need another 26. What can we do? We need 26 with 3 numbers. The best way to get there, I can see, is can I, oh, the difference has to be only 6. So if I am taking 12, I cannot take 4. But can I do this? Let me reduce 12 by, oh, what can I do? What can I do? I can't think of anything as of now. Let's wait. Another extreme case that I can see is 2, 4 and 6. This would be the minimum sum. Does someone have a minimum sum of 12? Yes, D has that. So D definitely has the values 2, 4, 6. Let's also put that into place. Now again, coming back to this extreme case, 26. How can I reach 26? Let me think. Can I have 8, 6 and 12? Yes, I can have 8, 6 and 12. So I will have, and the difference would also turn out to be 6 there. Brilliant. So I've got 12, 6 and 8 here. Now if you pay attention, all the 12s have been mentioned. 12, 12 and 12. 2s have been mentioned twice, once and twice. 4s have been mentioned twice, once and twice. 10s have been mentioned twice, 10 and 10. 6s have been mentioned twice, 6 and 6. But 8s, which should be mentioned thrice, have not been mentioned anywhere at all. So let me put an 8 here. So if I put an 8 here, the difference I'm getting, I will get an 8 here and I will also get an 8 here. Now see the 8 that I'm getting here, sum of all 3 types is 16. Difference is 6. The two numbers, the other two numbers involved will add up to another 8, and the difference between the highest and the lowest value is 6. Therefore the only case that satisfies this is going to be 8, 6 and 2. Let me put 8 is already there, so 8, 6 and 2. Now you can see 2 has been mentioned thrice, 6 has been mentioned thrice. The only numbers that have not been mentioned are, or that have not been mentioned 3 times are 4 and 10. And when you have 4 and 10 here, you will also reach a sum of 22. So all conditions have been fulfilled. As of now, I know these are the 3 numbers available with each of these friends, but I don't know how they get distributed. Let's work that around. The friend who has 2 lollipop chocolates also has 12 candy bar chocolates. So let me look for the pair where 2 and 12 are coming together. We don't have neither 2 nor 12. We have 2, but we don't have a 12. We have 2 here and we have 12 here. So 2 and 12 lollipops, 2, 12 candy bars. So 10 waffled here for C. Another, the friend who has 8 waffled chocolates also has 6 lollipop chocolates. 8 and 6. 8 and 6 have to come here together. 8 and 6 are coming here together. 8 and 6 are coming here together. Okay. The friend who has 8 waffled chocolates also has 6 lollipop chocolates. Okay. So I could have this being distributed here. But if I had, let's see, 8 waffled and 6 lollipop. If I had 8 waffled here and 6 lollipops here, then 12 would be candied chocolates, and this is impossible because I already have 12 candied chocolates with C. So this is an unacceptable case. So effectively 8 and 6 would not get distributed here. It would get distributed here, 8 here, 6 here and 2 here. Now because 2 2's have been mentioned, can I come up with the conclusion that D, that also has 2 of one variety, would only have waffled as 2. Now 4 and 6 have to be distributed. 6 cannot come here, so 4 will come here and 6 will come here. Now 2 6's have been mentioned. The third 6, which is mentioned here for F, cannot come in lollipop, cannot come in candied, so it will come in waffled only. Now because 6 has been mentioned here, 12 and 8 have to be distributed here. 12 cannot come here, so this will be 8, this will be 12. Now when you look at 12, 112 has been mentioned in lollipop, 112 has been mentioned in candied. So this 12 with E will necessarily be in waffled. Now I have 10 and 4 to distribute in these two places. When I have 10 and 4 to be distributed in these two places, 4 cannot come here. So here it will be 10, here it will be 4. Now I'm only left with distribution for A. Let's look at what is the number left in this L column. The only number left is 8. The only number left in the candied column is 10 and the only number left in the waffled column is 4. So now we have the precise number of chocolates with each of these friends. Another indication that should tell you that you should be able to reach precise answers in this case is every question has precise options. None of the questions have none of these or cannot be determined as options, which means precise answers can be obtained here. Which friend has the least number of waffled bar chocolate type? Waffled bar chocolate type has to be this number. So the answer has to be D. I think I made a mistake here. It should be D. Another, what is the difference between the number of candy bar chocolates with E and the number of waffled bar chocolates with A? Candy bar chocolates with E and waffled bar chocolates with A. So 4 minus 4, the difference is 0. How many friends had a greater number of chocolates of both the type lollipop and waffled bar than D? Lollipop and waffled bar than D. So more lollipops than D would come for F, but nobody can have more. Oh, sorry. We are looking for D. More than 4 and more than 2. Okay, more than 4 and more than 2 effectively means, will this get counted? Yes, A will get counted. Will this get counted? Yes, this will get counted. Will this get counted? No, this has fewer number of lollipops. This gets cancelled. Will this get counted? Yes. And will this get counted? Yes. So the answer to this question has to be 4. Which friend had the highest number of waffled bar type of chocolate? Highest number of waffled bar chocolate type comes with E. Therefore the answer has to be option A. And that is all the questions.